Hello dear viewers, you are most welcome and thanks for watching. This is L Jaled 2 Math channel, and if you are new to this channel, please kindly subscribe, turn on the notification button so that you are notified whenever I upload a new video, like and share. Tonight we are going to talk about how to solve equations involving logarithm. Specifically, we are going to talk of those equations that are having one unknown, as we can see here, and below that we have our number 1, which reads solve x in the following equations. Then we have part A, part B, up to part D. So I want us to go through them so that you can get used to how we get terminologies we can use, the tactics we can use so that you can solve for x in one of these given equations below. So please endeavor to watch up to the end so that you don't miss out any step. Like and share. So the only thing you can support this channel is to subscribe, give it a thumb up and share the video so that it can be helpful to other students and maybe other people who may be in need of it. So part A, we have log of x base 2 minus log of 8 base x being equal to 2. So we are going to solve for x. So in other words, what is the value of x? So we are going to have our response here together. Let's move together. So we are going to change these logarithms so that they are in the same base. So let's now change this logarithm to be in base 2. So for the first one, we are going to have log of x base 2 minus. So we are changing this log of 8 base x to b of base 2. And it's going to be the same as having the log of 8 base 2 divided by log of x base 2. This is equal to 2. So from here, we can simplify further. We are going to have the log of x base 2 minus the log of, so 8 is the same as 2 raised to power 3, then base 2 divided by the log of x base 2 still equals to our 2. Now from here we can see that the rules of logarithm, this one is gonna drop so that we remain with log of 2 base 2, which is now coming to be the log of x base 2 minus the 3 log of 2 base 2 divided by the log of x base 2. This is equal to 2. So we can proceed. So this implies that, remember, the log of 2 base 2 is 1. That means you have the log of x base 2 minus the 3 divided by log of x base 2 being equal to 2. Now from here we can let us let maybe m be equal to the log of x base 2, implying that as we substitute in, we are going to have our m minus the 3 divided by m equals to 2. So from here we can eliminate this denominator, which is m, by multiplying through by m everywhere. So as we multiply by m, it means we're going to have m multiplied by m minus the 3 out of m, but multiplied by m equals to 2 multiplied by m, implying that we are going to have our m squared minus 3, since this m and this cancels out, being equal to, the 2m. We can now bring this 2m on the left hand side so that we form a quadratic equation. So this implies that we are going to have the m squared minus the 2m minus the 3 equals to 0. So we can see that this is a quadratic equation. So now let's proceed with it. Remember, our equation is the m squared minus the 2m minus 3 equals to 0. So this is purely a quadratic equation which can be solved by any method which is suitable for solving quadratic equations. So in here we are going to use factorization because it is factorizable. So we are going to use factorization methods for this case. If you're not well conversant with the methods of solving quadratic equations, please, I'm going to leave the link in the description. Tap on it and watch all the methods that can be used to solve quadratic equations and why. So now from here, let us proceed. Let's get the factors. So we ask ourselves, remember the sum of the factor is -2, then the product is also -2. So we ask ourselves, which two numbers that when added gives us -2, and as we multiply them we get -3. So these factors are the -3 and the 1. So we are going to use this, so that if we add the -3 plus 1 we get this sum, which is the -2, as you can see. Also, as we multiply the -3 by 1, we shall get the product of the factor to be -3. So from here, as we proceed, this implies that we are having the m squared minus the 3m plus, so the 1m minus the 3 being equal to 0. So from here we can factorize out m. M is common, and here we shall have remain with m minus the 3 under the brackets plus, so the common one here is a 1 into our m minus a 3, close the brackets, equaling to 0. So from here you can see that m minus 3 is common, so we factorize it out under this brackets into, here we shall have remained with m, then plus this plus here plus a 1 being equal to 0. So from here you can see that either the m minus 3 equals to 0, implying that our m equals to a positive 3, or m plus 1 equals to 0, implying that our m equals to the -1. So when it crosses the equal sign, it is becoming to be a -1. So far we have got the answers for m. Remember, the question asked for the values of x, as you can see from part A. So, but remember, we let the m to be the log of x. So let us proceed with this. But m equals to the log of x base 2, implying that for m equals to 3, it means that our log of x base 2 equals to 3. So as we simplify this, we change it from logarithm to indices. Remember, this 3 is the power. We say this is the power, then this is the base, and this is the number. So it means that we are going to have the x being equal to the base, which is 2 raised to power 3, meaning that our x equals to the 2 multiplied by the 2 multiplied by 2, implying that our x equals to 8. So this is our first answer we have got, but we have to proceed. Also, for m equals to the -1, it implies that our log of x base 2 equals to the -1. So the same way, this is the power, this is the base, and then this is the number. So this implies that our x also is equal to the 2, which is the base, raised to power -1, which is the power. X is gonna be equal to, so 2 raised to power -1 is same as 1 divided by 2. So this is now the second answer for the value of x. Let us now conclude. Therefore, that means for part A, therefore x equals to 8, and still x equals to a half. So this becomes the values of x. We can now proceed to part B of the question. As you can see it, part B, they have given us the log of x base 5 plus 2 log 5 base x being equal to 3. So the same thing, let us make all the logarithms to be in the same base, and let us maybe convert all the logarithms to be in base 5. So it implies that we are going to have the log of x base 5 plus, so this is the same as having the 2 multiplied by the log of 5 base 5 divided by the log of x base 5 being equal to 3, but the log of 5 base 5 equals to 1. So now let us substitute. It implies that our log of x base 5 plus the 2 multiplied by 1 is now divided by the log of x base 5 equals to 3. So this is the same as, so from here we can now let y be equal to the log of x base 5, implying that from this equation here, it means that we have y plus 2 divided by y equals to 3. Let us multiply by y everywhere. So we are going to have y multiplied by y plus the 2 divided by y multiplied by y equals to the 3 multiplied by y. So as it proceeds, this is the same as having the y squared plus 2 equaling to the 3y. Let us take this 3y on the left hand side so that we can form a quadratic equation. So this implies that our y squared minus the 3y plus 2 equals to 0. So this is also a quadratic equation, and we are going to solve it by factorization still. Let's now talk of the factors. The factors are, so which two numbers, when we sum them we get negative 3, and then when we multiply them we get positive 2. Those two numbers are the negative 1 and negative 2. So we can prove this. If you add these two numbers, so negative 1 plus negative 2, we get negative 3, which is the sum of the factors. Then negative 1 multiplied by negative 2 shall get a positive 2, which is the product of factors. So from here, the next step, we are going to substitute in. For where there is negative 3y, we just put this. So we are going to have y squared minus y minus the 2y plus 2 being equal to 0. So let us pull out y. So it remains y minus 1 minus, let us pull out 2 into y minus 1 equals to 0. Still let us pull out y minus 1, which is common, into the y minus 2 being equal to 0. So from here you can say that either y minus 1 equals to 0, implying that our y equals to a positive 1, or y minus 2 equals to 0, implying that our y equals to the positive 2. So far we have got the two values of y. So remember, we let the y to be the log of x base 5. So now the next step, we can proceed and get the values of x. So we say that but y is equal to the log of x base 5, implying that for y equals to 1, it means that the log of x base 5 equals to 1, whereby this is the power, this is the number, and the 5 is the base. So in form of indices, it means that we are going to have our x being equal to the 5 raised to power 1, implying that our x equals to 5. Then for y equals to 2, it implies that our log of x base 5 equals to 2, whereby this is the power, the 5 is the base, and then x is the number. As it proceeds, we are going to have our x being equal to the 5 raised to power 2. It means that our x equals to the 5 multiplied by 5. This gives us the value of x being the 25. We can now conclude and say that therefore for part B, the value of x equals to 5, and still the value of x equals to the 25. So this becomes the right answers as the values of x for part B. You can now proceed. Part is reading 3 log of x base 2 minus log of 2 base x equals to 2. So we can proceed with part C. We have the 3 log of x base 2 minus log of 2 base x be equal to 2. So the same thing, we can decide to change all these logarithms in the same base. Let us change them to be in base x. So this implies that we are going to have the 3 multiplied by the log of x base x divided by log of 2 base x minus the log of 2 base x being equal to 2. So remember that log of x base x is also equal to 1. From here, that means we are going to substitute 1 there. So it implies that we have the 3 multiplied by 1 divided by log of 2 base x minus log of 2 base x equals to 2. So from this, we can proceed by letting. So let us maybe we let m to be equal to the log of 2 base x. So it implies that from this equation here, that we are going to have the 3 divided by m minus m being equal to 2. So let us multiply by m everywhere. So we are going to have the m multiplied by 3 divided by m minus m multiplied by m equals to 2 multiplied by m. So this m and this, they cancels out, so that we remain with 3 minus m squared equals to the 2m. We can now make this to be a quadratic equation. So it means that we are going to have m squared plus the 2m minus 3 being equal to 0. So this is a quadratic equation, and we are going to solve it by factorization because it is factorizable. So it means that from our equation we have m squared plus the 2m minus 3 being equal to 0. So let us look for two factors or two numbers that when we sum them we get 2, and when we multiply them we get negative 3. What are those values? And we are calling them factors. So the factors, I can see that it shall have a 3 and then negative 1. We can prove this. If we get this 3 plus negative 1, we shall get a 2 which is positive and it's a sum. And then if we get 3 multiplied by negative 1, we shall get our negative 3 which is the product of factors. So from here we can now proceed, and we have our m squared plus the 3m minus 1m which is minus m minus 3 be equal to 0. So let us factor out m. We are going to merge with m into m plus the 3 minus, let us pull out 1 into m plus a 3 equals to 0. Let us factor out m plus 3 which is common. So we have m plus 3 which is common into the m minus 1 being equal to 0. So from here you can see that either m plus 3 equal to 0, implying that our m equals to the negative 3, or our m minus 1 equals to 0, implying that our m equals to a positive 1. So from here, remember we let the m to be the log of 2 base x. So we can say that but m equals to the log of 2 base x, implying that for m equals to the negative 3, it means that our log of 2 base x equals to negative 3, whereby this negative 3 is the power, x is the base, and then 2 is the number. What does it mean? It means that x raised to power negative 3 equals to 2. So now from here, to get the value of x, we are going to have the x, which is negative 3, being equal to the 2. So let us multiply this by 1, negative 1 divided by 3 on both sides. So in here, we are going to have the negative 1 out of 3. So that this one, we are going to have the x raised to power 1 being equal to the 2 raised to power negative 1 out of 3. Also, for m equals to 1, it implies that our log of 2 base x equals to 1, meaning that x raised to power 1 equals to 2, whereby we have our x being equal to 2. We can now proceed and give a conclusion that therefore x equals to the 2 raised to power negative 1 out of 3, and still x equals to a positive 2. So this becomes the right answers for that part C. So we are remaining with part D here, and please try out part D on your own, and please drop the answers, drop the values of x in the comment section. Thanks for watching. See you again. Goodbye.